Hello. As agreed yesterday, we'll go together over the main Streamlit application file, line by line or section by section, to give it more meaning. So, in first part, you can see the import section where we are importing different libraries which are required for our code. Streamlit for an interactive web interface, NumPy, a powerful library for numerical computing, which handle our array and data operations. Pandas is a data manipulation, which we used before. Basically, this is reading the CSV files in our project, which are generated in data folder, and handle stock data. Yahoo Finance is the source of our information from where we are getting the stock pricing data. Plotly or Go is for generating interactive charts and graphs. Next is JobLib, which is used to help us load machine learning models that have used in our code. We're importing OS to have access to operating system. Datetime and delta are for handling date and time operations for setting ranges in our code. sklearn pre-processing min-max scaler is a scaling tool used to normalize the data within the range 0, 1. sklearn metrics is used for defining the mean absolute error and mean squared error. Those are metrics that we are using in our daily, in our estimation of how successful the prediction was. Let me actually better share you the file that I'm using for monitoring the stock prediction. You can see here I'm using much larger number, but this is something manual. So mean squared error means that to the predicted price we should add the square root of the MSE value. Like let's go on linear regression, which means that the prediction is that it would be in range of 571 plus or minus root square of 25.41, which is roughly 5. So it will be in range from 566.3 to 576.3. 571 plus or minus 5. Mean absolute error is numeric is a value like plus 571.3 plus or minus 3.8. So these three, and MAPE, which we are not covering in our exercise, but it can be useful for you to know, it's mean absolute percentage of error. So this is percentage, so 0.88% of 571.3 is in range, and here I have coloring scheme which is comparing the actual price to the one that is predicted, and predicted price we are adjusting using all of this. So if the actual price is in range for predicted price plus or minus MSE, it is green. If it's not, like in this case for Amazon stock for the same model, it is red. You can see it's 192 and 1168. The square root of it is basically 3.5, and we can see that the actual price was out of range, 192 minus or plus 3.5. So this covers it. Let's go forward, and we import TensorFlow Keras models, which are pre-trained neural network model for which saved in Keras format. Next, we are loading our S&P 500 stock file access to base directory of the project, CSV file path, and the name of what we are saving the data from our file. We are saving it as from CSV file as a pandas data frame, which contains stock tickers that will be used to fetch stock data. We calculate moving averages of a specified period. We will provide that period later on in our code. We're creating data set, preparing the data for training and prediction with a machine learning model. The look back equals to 100 number of days or time steps the model will use for predictions. X is the input features, previous 100 days. Y is the target variable, the next day price, and our for loop goes over the range of dates and creates a sliding window of the past look back, which we defined 100 in here for stock prices, and then it is used as an input for prediction. Then in our main method we are defining or writing the Streamlit page design, how it's gonna look. We are adding a sidebar, we're adding a description to the sidebar, what it does. Next are the drop downs for the ticker selection, for start date, end date selections. Next there is a radio button which is used for selecting one of the available choices in a range of prediction models. Next we are going over the data download phase, where we are getting from Yahoo Finance the historical stock data, open, close, high, low, and volume for the selected stock for the dates between start date and end date. We are writing the first 50 rows of data, downloaded stock data, in the Streamlit app. Next we are calculating moving averages and displaying in a plot moving averages versus the actual price. Next we are getting over the candlestick chart for open, high, low, and close daily stock price variables. Next we have a volume figure which displays like the volume of shares traded over time. Basically this is helping us to understand the stock liquidity, so how desired it is, how much what is the trade volume means how interesting it is for investors. Next we are loading our machine learning models, neural network for example. We are loading the files in Keras format from the specified folder. We are doing the same for the random forest and linear regression. Those have PKL files. Next we are scaling data for prediction with scalar min-max module from a range from 0 to 1. Next we are creating a data set which prepares the data for model prediction by creating a sliding window of 100 days. We defined it earlier in our code. Next goes reshaping for the model input. For neural network we are reshaping the prediction data to the correct format for it, 3D array, and inverse scaling here transforms the predicted data back to original scale using scalar. Next, we are plotting original versus predicted prices in the plot. Then goes the evaluation of our model with MAE and MSE. Next goes our 30-day forecast from 1 to 31, where we are predicting basically the stock price for the next 30 days based on the trained model and based on the data that we got for last 100 days. And we are providing a subheader to display it, and like the global idea of our app is to analyze the stock prices, based on the analysis predict stock prices, and do a forecast based on the selected model. Hope this was helpful. Our next video will be for the first of our prediction models, linear regression. Stay tuned for the updates. Hope you enjoyed it, and see you next time. Goodbye.